Hi, this is Mike Lawless, and in this video I'm going to show how to incorporate experimental liver microsomal clearance data into GastroPlus simulations. I'm just going to give three simple examples. The first two are use the unit converter to enter the data. And the first one I'm going to use human species and human liver metabolism microsomal clearance data. The second one I'll use rat liver microsomal clearance data. And then the third example, I'm going to create a file that contains rat liver clearance data that will be imported during the same time that the structures are imported. This slide shows the structure of the compound I'm going to import. The human liver microsomal clearance data comes from this journal article in Journal of Medicinal Chemistry. The intrinsic clearance is 465 microliter per minute per milligrams of microsomal protein. This compound was also used to perform a rat PK study, and there they used an oral solution dose of 5 mg per kg, and so that's how I'm going to set up this simulation. I have started GastroPlus, and the first thing I'm going to do is create a new drug database. So I will navigate to the area where I want to create the database. I'm going to create an empty folder there just to house the database files, etc. And again, I'll just call the database LM. So it starts with a blank record, and then I'm going to import Smiles file for this the first molecule that we want to look at. And so that's compound 1 file here. It will open up the import structure box. I'm going to change the formulation parameters when I get into GastroPlus, or back to GastroPlus. Right now I'm going to create a new human physiology based on a 45-year-old man. Save that in the same directory as the database. I'm going to change the renal clearance to FUP times granular filtration rate, and then I'm going to specify none for the clearance because that's what I want to import or read from the publication. So I've read the new record in. I'm going to delete the first blank record, and then it takes me to this current record. So first thing I'm going to do is change the dose form to a solution. It tells me that I need to shorten the stomach transit time to 0.1 for this. I'm going to do 5 mg per kg. This subject is about 90 kilograms, so this should be about a 450 milligram dose. So I change that there, and then I'll go into the gut physiology. Here's where I would want to make my change to indicate the shorter transit time. And I also want to save this as a new physiology. So I'll go under File, Save, Save ACAP Model, and then say 0.1 hour transit for the solution. Save that, and that'll save it in the database directory. So now that's updated the physiology here. Now if I go to the Pharmacokinetics tab, you'll see that we don't have any clearance in the liver currently, so I need to go to the modules pull-down menu and click on metabolism and transporter. So this lets me set up the conversion of the clearance from the in vitro value to the in vivo value. First thing I'll do is use the Austin method to calculate the fraction unbound in liver microsomes. And for this particular molecule, the fraction unbound is predicted by this equation to be about 17%. Then here's where I need to enter the value from the clearance, which on the slide was 465, and it was in microliter per minute microsomal protein. So I need to change this to the appropriate units, which is microliter per minute per milligram of microsomal protein. That converts to a liver clearance of 11,000. Now I'll just click Transfer Unbound to the in vivo, and you'll see that it's updated the liver clearance value here. Now I'll go into the Simulation tab and just click Start to perform a 24-hour simulation. And we want to look at the FA percent. So this is the fraction absorbed predicted from GastroPlus. The FA and FDP will be the same because we don't have any metabolism going in the gut wall. We haven't specified any metabolism there. It's all occurring in the liver, and you see that the oral bioavailability is predicted to be 51%. Now in the second example, we're going to use the same molecule, but here we're going to set up a rat physiology and use the rat liver microsomal clearance value here of 241 microliter per minute per milligram of microsomal protein. Again, it's a 5 mg per kg dose, and here we've got an oral bioavailability of 31%, so we can compare our prediction with that value. So now we'll go back into GastroPlus and perform another import of this structure. So again, import structure. Again, it's compound 1, so the structure of the compound's not changing. It's the same compound. Here, though, we'll create a new physiology for a rat, and then click OK here, and save that physiology in the same database. We use the fraction unbound to liver microsome, and again have none for the liver clearance values here. So that'll import that compound. Now you got to remember, when it imports it, it switches back to the first record. So we want to move on to the second record. You also see how it added another -1 to make this a unique record name. So again, we'll specify a solution for the dose. Again, it warns us about the stomach transit time. So this is a 5 mg per kg dose. This is a 0.25 kilogram rat. So this dose should be 1.25 milligrams. Then we'll go into the rat physiology again, change this to 0.1. And then we will save this again as a different or a different file name. Again, now here we'll call it rat 0.1 hour stomach transit because it's a solution. Click OK and say yes, we want to save this physiology here. Now we'll go up to the Pharmacokinetics tab, and you can see that the liver clearance is currently 0. Again, go into the metabolism transporter module to enter the clearance value. This is microsomal clearance here. Again, we'll use Austin. This time we're going to use a fraction or a clearance of 241. And then once we click change that, it updates the intrinsic clearance. One thing you can also do is look at the advanced options, and you see that the tissue weight for the liver is 11, which is appropriate for the physiology we have. Transfer this over back into GastroPlus. Here now the intrinsic clearance is 35, and this is in liters per hour. And then this clearance is about 0.22 liters per hour. And this is calculated using equation for the well-stirred model. Then we go into the simulation tab and start the simulation. Now we get an oral bioavailability of 59%. In this last example, I'm going to perform simulations on these 3 molecules here, and I'm going to import the structures and also the data with the file. So I'll import the RML data, the dose, which is different for each one of these compounds, and also the observed values associated with the compound. The 3 molecules that I'm going to import into GastroPlus are displayed here in ADMET Predictor. You'll see that there's a column called GP dose. When you see when I import this that GastroPlus knows that this is the dose, and then I'm going to have to specify that this is the observed values when I import the file, and then these values are the rat liver microsomal clearance values. I've started GastroPlus, and the first thing I'm going to do is create a new drug database. I've already created this directory rm import, and so that's where I'm going to save the database and just simply call it lm import, rlm import. Open the drug database, it creates this blank record, and then I'm going to go under File, Import to import the structure file. Again, this is in the same directory as the database. You'll see that for the dose in milligrams, it's automatically picked up GP dose information. For the PK model, I'm going to create a new one again that specifies rat physiology and save that into the directory as the database. Change this to FUP times GFR, and then here I'm going to set these to none, and then for the clearance I want it to pick up the RLM data from the file. So I simply specify it there, and then I need to specify the unbound fraction. Again, I'm going to use the Austin correction method. For the observed values, FB is also known as the oral bioavailability, so I'm going to set that to rat F%, and then click OK, and it will import the three records. Again, it goes back to the first record. I'm going to delete that blank record. So if we look at the first record, we see the structure up here. We see the imported dose of 1.25 milligrams. Then for the dosage formula, I want to change all these to the same value. So here I'm going to go up into database. I'm going to unlock all the records for a batch update, and then edit the drug table, which specifies the dosage formula here. So when I bring up this table, I need to scroll over to the area where it says the dosage formula. I'm going to change this to a solution, and then we can also update, right click, update all the records with this value, so it updates them all into solution, which is what we wanted here. Then we can also, we'll save this record. Now we'll look at the gut physiology. As we've seen over and over again in this example, we want to change the stomach transit time to 0.1 hours. So we can do that here, and we'll save the ACAT file here with this physiology. Again, rat-0.1 hours stomach transit, and that's for a solution. So we can save this, save it in the database, and then again we could go up here to the edit the drug records. So we need to scroll over quite a bit for the physiology. You see it's about 3/4 of the way over, and again we'll right click and update all rows with this particular value. Click OK, and then we want to save that. Now here's the first record, and you can see that it's stomach. You can use Control N, which goes to the next compound, compound 2, and you'll also see that the physiology is correct here. Now if we go into the pharmacokinetics, again we're on drug record 2, but you see that the liver clearance here was imported from the file. Let's go to the next record, which will be the last, and again you'll see the clearance is correct. So here we can go back into the first file, go into simulations. Now we could perform a batch simulation on all these records. I'm going to do them individually though. So I'm going to start the run. This was the first record, and it's the same as in the first example I performed initially. Okay, now we'll go to the next record, start that simulation, and again you see you get a different oral bioavailability here, and you can compare it to the observed value. And then finally on the third one, I'll do another simulation here of this compound, and then you'll see the results there. So that's how to run these. If we want to do it in batch, we could just click on the batch simulation here and then specify our output file, click OK, and then when we run these in batch, it will first prompt us for a text file to save the results on. I click OK, and then it will loop through each of the three species or through three compounds, and when it's finished, will indicate that it's done. And so that completes the video. Please let me know if you have any questions. Thank you.